Well, welcome to today's webinar, GIS for Subsurface Utility Engineering Compliance, part of the Connect Me Asset Mapping events, GIS and AI for Local Government Compliance Reporting and Asset Management Series. I'm Mark Goldman. I'm Director of AEC Industry Solutions at Esri. I'm going to be moderating the event and hosting the Q&A later in the presentation. Before we get started, though, we do want to run a quick poll of the audience. It's always great to know where you are from and what industries and sectors you work in. The poll should have popped up on your screen. It'll stay there for a few moments, but we would really love to have as many folks as possible to vote, participate. Let us know what type of organization you're with and geographically, pretty broadly geographically. Let's say what country or continent you're from. And again, just helps us know where people are connecting from when it is across the globe, and certainly what industry just also provides us a lot of context to the way we will be presenting our content over the next while. This is one of, I think, two polls that we might be doing, maybe three towards the end here. So please take a moment and let us know how where you're from organizationally and where you're from geographically. And then also, two more questions, your business area. We want to understand, again, helps us with context, which is so important with GIS, sort of what types of projects you work on. Public versus private, utilities versus emergency, sustainability, focus. This would be singly one of those choices. And then finally, sort of a where you're from kind of question, the size of your municipality, the city you live within. These are all helping us as we talk about subsurface utility engineering. So please take a moment and fill out all four questions. I only had two on my screen at first, and maybe you'll fall for the same thing. Make sure you scroll all the way down and get to four questions that are, again, just kind of helping us understand your perspective on things. So let's see, has that poll closed yet? Let's see, here we go. Mostly local government, really interesting. Boy, overwhelmingly local government, with a few scattered across industry, other, and state government. United States, that's what we typically see. No surprise for this first broadcast live at this time of day. And then public works within the state and local governments as well is predominant in cities that mostly are either quite large or smaller. Interesting stats here. And again, that will help us just have some context of who we're talking to. For information about the speakers, we've got a great lineup. Folks we've connected a couple of times. Myself and the first presenter after me actually met in person recently. If you want to find out more about them, click the resources tab at the bottom of the Zoom dashboard. We've also shared some links, some resources to the various companies and documents and downloads and web pages and case studies that might help you understand more after the webinar. This session is being recorded and will be available for download on demand after the event. You'll receive an email notifying you when you can access the recording. So thank you for maybe taking a second pass through it. We'd like to thank our webinar series sponsors, Carasoft and Bad Elf, for making these educational opportunities available to the industry. This is a webinar series that I always enjoy participating in. Well run, great messaging, great presenters always lined up. Today, in addition to myself, is Kevin Hashem, the VP of Engineering at Land Survey, Certerra, Subsurface Imaging. Kevin and I met, like I mentioned, recently at a conference and immediately knew he'd be a great resource for this audience. Marvin Lopez, Client Success Director at PointMan by ProStar. PointMan's a great solution that Marvin and I are going to be diving into offline as well. So I'm eager to connect on that and get a impression here as well from the audience and get questions back on it. Kenneth Smith, a utility field technician, someone who's really using these tools on a day-to-day basis. And then finally, Dr. Nick from Bad Elf himself will be wrapping things up. This is a topic that's somewhat near and dear to me. My focus is broadly across all of AEC, but the idea of subsurface utility engineering keeps crossing my paths in a real deep manner. So let's go ahead and get started. I'm going to go ahead and share my screen just to kind of kick things off and level set. some topics here. So again, just a reminder of the title, GIS Solutions for Subsurface Utility Engineering Compliance. I'm going to focus on the GIS. No surprise, it's it's what I live and breathe these days. It's what I am immersed in. It's what I've realized is really a secret sauce in the world of infrastructure, one that I don't think was as widely adopted just a few years ago as it is certainly now, and its importance in any aspect of engineering, much less coming to understand a level of context that typically you can't see visually. GIS is more than just the mapping that might come to mind. It supports field operations. It's a platform for spatial analysis and the data sciences that have become so important in today's world. It's a means of describing context through imagery and remote sensing, giving real-time feedback and conditions of various infrastructure environments. It is this visualization and analytics overlaid on top of each other. So not just a pretty picture, but an insightful one, and certainly 3D as much as 2D, at least in the world of infrastructure, built worlds, architecture, engineering, construction. And it's an analytics against that 3D visual as well. So again, not just pretty pictures, but analysis of information in this platform that many use as their data management hub, as their system of record, as their means of collecting all of the type of information for infrastructure in so many formats. And in the case of Esri, available through developer APIs. So if our solutions on the desktop, in the cloud, in your hand as a mobile device aren't fitting the bill exactly, there's means of developing exact specific solutions. And these all are built around answering questions of where. And there are so many where questions, certainly as it pertains to subsurface utility engineering. And starting just at that level D, where essentially it's about information that is from existing records and even called urban folklore, oral recollection, I think is the exact term. Where are the underground utilities? From public records, from basic records, from conversations, from just collecting, doing basic research. Where are the utility easements? Where are they recorded? Where are they expected? And maybe do an analysis of where that difference is. Where are there incomplete utility records? Where are your gaps in information that then can lead you to bid on a project or understand a project or execute a project most informed, knowing what you don't know? Where do the utility maps perhaps even conflict with as-built conditions? Because we all know as-built rarely are truly as-built. So at this level D, using GIS to answer these questions of where is kind of an obvious. At level C, where it's more about a sort of a visual survey, let's call it. It's the correlation between what you see and what the records indicated. Those are going to be things like traffic corridors and where are they relative to utility alignments? Where are the points of utility access, the valve covers, the manholes, the hydrants, the furnishings? Where are they relative to utilities and the work that needs to be potentially performed? Where might surface conditions vary from what your maps show you and where utility lines might be? Imagery helping to inform that. Where are the above ground clues sort of misleading, inconsistent with what your records show you? Again, sort of that as-built, not comparing to. And then into level B, where it's about, this is one that really has caught my area of interest recently, this area of understanding subsurface through GPR or electromagnetic, or I found some other companies who are using multiple sensor types and then AI to combine them and understand where are the known utility lines located horizontally to a high degree of certainty. Where might those utilities conflict? Again, based on what's marked in the field, what might be abandoned, decommissioned, but yet still detectable, critical for your construction planning, your safety, and such. Where might vacuum excavation really be the right tool based on what you're getting through the geophysical, through the geotechnical information that a GIS can provide to you. Where certainly, the importance of safety, where things are, where people are, where your work is taking place, where might you have trenching or shoring issues to consider based on these ground conditions that you're able to identify and visualize with GIS. And where are the utilities perhaps intersecting with transportation or rail? The investments in transportation and rail and the intersection with utilities, the opportunity to come to these projects most well-informed is significant. And then finally, level A, where you actually are physically potholing, vacuum excavating, moving beyond sort of just the technologies of understanding what's underground, but actually investigating, through daylighting, through confirmed test holes, and on and on. I mean, the point here, I didn't want to belabor the point, but it quickly becomes this, wow, GIS really does serve a unique platform, foundation, source of insights, analysis that other platforms just don't do. GIS answers these where questions, and where is so important as it pertains to our built world. And specifically, it's in areas where you need to assess what is existing compared to what your plans might be. And you're not going to do that in a CAD tool. You're not going to do that in a BIM tool. You're not going to do that on paper. Modeling those conditions, understanding through survey, through data collection, and through the ability for multiple layers of information to be brought together to then simulate potential conditions, worst case, best case, and come out with a solution that then you can get out of your traditional engineering tools, your traditional tools that require a deep level of expertise, but you might want to expand that information beyond. And these are the things we're going to see in the projects presented by our speakers. In this area of assessment, it's about bringing layers together. This is actually an underground utility map from one of the largest most innovative construction companies here in the US, who are combining data layers, understanding the context of space in an area that you just can't see, below ground utilities of a solar farm installation. Modeling, this idea that modeling is typically 3D. Modeling in our built world is again, understanding conditions, understanding flow, understanding traffics, understanding networks, and generating visuals that tell a story in ways that is quite unique. And again, not what you would get out of a project planning tool, a Gantt chart, an Excel spreadsheet, but visualizing this information for modeling purposes and simulating the real world conditions through the collection of this data, these underground existing conditions, and having it be part of an entire digital twin, as we see here in this example. And finally, what I think is most interesting and has come to mind for me is that GIS provides this interactive, typically web-based or mobile-based way where a broad group of stakeholders can understand the conditions that are going to affect their life and sometimes even weigh in. It's the level of transparency that we all are seeking in the world as it affects us. And then last but not least, this idea that GIS is an iterative tool. It's one of the few platforms that allows you to understand conditions, perform some what-if scenarios, and then make your decisions based on often real-time feedback and feedback from various sensors and such. So with that, I'm going to hand it over to Kevin Hisham, who is going to dive in deep to how these technologies actually come to play, answer those questions of where on some real-world projects. Take it away, Kevin.
Good morning, everybody. My name is Kevin Hashim. I work for Certera. We are a subsurface utility locating and mapping company here in Southern California. So we work with subsurface utility locating and mapping. I'm the Vice President of Engineering of Land Survey here at Certera. Any construction project, there is a possibility of accidents or damages. And that's really associated a lot with the subsurface utility, that we can say that they are out of sight and they are out of mind. People are not really understanding the importance of how to locate for the subsurface utilities before you dig. It was estimated that in 2023, the damage associated with the utility destruction on construction sites was about $30 billion. So anything can go wrong. If there is a gas line and the contractor dig before locating. So they might cause huge damage, like when they hit a gas line, or if they hit a water line. Therefore, there is a subsurface utility engineering branch of engineering that involves managing certain risks. There are the unforeseen underground issues, utility locating and mapping, utility coordination and research, and it also involves in the utility design. To handle these issues and to standardize them, American Society of Civil Engineers produced and provided ASCE 38-22 standards. In the ASCE 3822 standards, they assigned level of accuracy of the subsurface utilities. They gave them 4 levels. They gave them level A, level B, level C, and level D. Level A is the most accurate, meaning if we assign level A to a subsurface utility we have been located, that means we are 100% accurate about the location of that utility. So utility quality level A, based on the ASCE 38-22, it's the precise horizontal and vertical location of utilities obtained by the actual exposure and subsequent measurement of subsurface utilities, usually at specific points. I'm going to go through in the coming slides on the methods that are used for each of these levels. Then level B, which is less accurate than level A, and it's the application of appropriate surface geophysical methods to determine the existence and approximate horizontal position of subsurface utilities. Then there is level C, which is the visible above ground features, along with correlating this information to quality level D information. Level C deals with the features on the surface at the site that indicates about what type of underground utilities are on site. So if we see a fire hydrant, that means there is a water line under the surface. If we see a catch basin, that means there is a storm drain pipe under the site. Then we have the lowest level. It's a quality level D, which deals with information that come from record maps or as-built maps that are derived usually from the utility owners. Now I'm going to go through the methods and equipments that are used and the process workflow to generate and work on this subsurface utility locating. So I'm going to start with the potholing. Potholing used for level A. That means we do create a pothole and we locate the pipe. This, as you see here, this is the hydro vac that is used to cut into the dirt and the undersurface all the way till we can locate the utility. Then we use the GPR, ground penetration radar, and it's there's types for it. We have the handheld, that's to locate rebars on walls, or also the cart that's to locate the underground utility in the site. There is the utility locating equipment that works with the electromagnetic fields. It generates in this system a signal is generated, and then the receiver detects where that signal is along the underground utility pipe, and so we can locate it. Then we have the CCTV methods as well, which I'm going to go through. And then after this, all the field work is done, a surveyor crew is sent to the field. They do the mapping, and then the data collected from the field goes to reporting for any CAD platform. So I'm going to start with I'm just going to show some images, videos from site work. For instance, we locate the utilities. We have the hydrovac rig. all what we do is like we dig till we find the utility. So this is for level A. That means we are 100% and we are really sure and that the locating or the utility we are finding is 100% accurate in regard to its vertical and horizontal location. So after we dig, of course, you have shed some light. You look there and you confirm that you find the utility you are looking for. And here is the pipe. Usually, before we backfill, you have a survey crew that go ahead and shoot the top of the pipe. Of course, when this utility goes in the mapping phase, this utility is assigned as utility level A. Here is the ground penetration radar. As I said, it's used to detect rebars within walls. Contractors, if they want to punch holes or create new conduits in concrete walls, they don't want to hit rebars. So they use this technique to locate actually the rebars in the walls. Here is the GPR card. What it does, it sends signals that goes through the ground, and then once it hits the utility pipes, it's get reflected, it's received back by the GPR unit, and the technician watching the screen here, he can see that they actually did or find a utility at that location. Then what they do, they paint, they put a paint mark to locate it. They take this GPR card and they go in a grid manner to cover the entire site. It's used to locate rebar, utilities, cables, voids, conduits, and also it worked with concrete, masonry, asphalt rock, and it goes through also the soil. Here's another image for the ground penetration radar on location. As you see, apparently here they found maybe a storm drain or a sewer line because it's marked with the green. I'm going to go with the color standards later. Utility locating using electromagnetic signals. This is for level B. So in level B, you have the base and you have the receiver. The base is connected to features above the surface that are connected to the line or the utility line that goes underneath the surface. So this can be connected to a water meter, gas valve. The signal sent, the electromagnetic signal is sent from the base, and the technician starts sweeping in the area, trying to find that signal. Once it's found by looking at this screen, they know that they found the utility and they go ahead and mark it. So this is used for level B, just like the GPR is. It's used for water, gas, waste, power, communication, and generally it's good. It's good with the concrete, masonry, asphalt, and rock, and soil penetration. The downside of the electromagnetic, it's only used with utilities that are steel. So that's why we resort to the GPR at the end of our work, because the GPR can locate any type of utility, whatever its material is. For the electromagnetic, the signal needs a steel medium for it to travel. Here is the technician doing the sweep. Here, the guys here are connecting the base to maybe like a cable or communication lines, so they can trace it. So they can trace the electromagnetic signal afterwards. Once they find it after they sweep in here, they go ahead and they put a paint to locate where they found the signal. Strong. If the site is covered with dirt and soil, of course the paint will not be that practical. So they go ahead and they put flags to indicate where the lines are. Here's a sample where they connect to. They can find, let's say, maybe like this one. This technician found a vault with maybe a valve. So they connect with a clamp this base to this valve for the signal to go through the line where they can find it or locate it afterwards. Also, we use the video pipe inspection, the CCTV. The CCTV, it's pretty much a camera connected at end of a cable that's being pushed in the lines, mostly storm drains and sewer. So the camera, while it's pushed and driven along the pipe, it can detect if there are damages in the pipe. It can locate cracks, roots, corrosion. And at the end, what's delivered is a CCTV report and video that show the designer the condition of this pipe. Also, at the end of this camera, there is a transmitter. So when the camera is going through the pipe, it also transmits signals. And at the surface, a technician also can locate where this camera is going, and they can also mark where this utility line is going underneath the surface. Here is some of the findings. They might find like a blockage. So the designer can know if they need, for instance, in this one, we can recommend that this pipe needs to be jetted. So they apply a pressurized water to clean the pipe. After the locating has been done, so we send the surveyors, we can use, total station or a GPS to collect the markouts from the site. Then there's the 2D utility map. It's used for the design and construction, depicts horizontal location of utilities in relation to fixed surface features. Estimated depths are given. It's excellent for horizontal conflict determination and can be printed and used by field personnel for construction purposes. Those are the findings that are depicted on CAD platform, which we are trying to migrate to a GIS for our the deliverable. Here you can see, for instance, for this site, you can see that the water is in blue, the gas is in yellow, the storm drain and the sewer is in green, and that's all based on the APWA, American Public Work Association. They give the standards for what to color each utility. And then in the findings in the report, we can mention that, for instance, at this location, like there's a direct buried communication line not shown on record drawing. So we are showing that the as-built map, for instance, which is level D, did not show a communication line that was located using, in this case, level B method. Again, a new fiber line not shown on record drawings that was located. Here we can also verify what's shown on the level D. For instance, there is an electrical line that might not be there, and we confirm that actually it's not in that location anymore. We can find discrepancies of water line. For instance, here is water line location between record drawings and actual field conditions. We also provide depth estimate. For instance, you can find, let's say this gas line, we at this point where the mapper found it, where the technician who located the gas line shows that there is this gas line is actually 6 feet and 9-inch deep. That's for my presentation. Thank you all for joining, for your time. I'm gonna now hand it over to Marvin and Kenneth.
Hello, everyone. Thank you for joining us today. Kevin, thank you so much for that wonderful presentation. That's a perfect introduction to kind of what it is that we'll be doing, what we talk about when it comes to PointMan and other utility mapping. So let me just throw this presentation up real quick, and so that we can all take a look. I'm not sharing screen, so let me have that. Okay. So before I begin, let me just introduce myself. My name is Marvin Lopez. I'm the Director of Client Success here at PointMan by ProStar. What that means primarily is my job is to talk about all things PointMan. I do a lot of onboarding with our clients, a lot of real world kind of training, continued success. PointMan's used in a variety of different ways. And so I'm here to kind of talk about specifically how PointMan has been used for SUE and kind of modernizing what SUE is. With me, I have Kenneth Smith. Ken, if you'll introduce yourself real quick, if you don't mind.
Yes, hello. I'm Ken Smith. I live in Fort Myers, Florida, work for a utility, and I utilize PointMan and to collect data on underground facilities in order to do efficient designs.
Thank you, Ken. Guys, really what we're trying to talk about today in specific PointMan or other mobile mapping solutions, it's not just PointMan, there are others out there, but what obviously my experience is with the PointMan solution, we're talking about the gaps in the traditional utility locating, things that were new technology 20, 30 years ago have now been caught up with even better technology today. That includes digitizing a lot of these paper records from things like as built, any information that's filed away in cabinets or other third-party softwares. We are taking what used to be something that could be a multi-week process of getting all this data and information together and putting it into the hands of everyday users. Like GIS tools that are like Excel sheets and PDFs and stuff like that, they don't necessarily meet today's modern compliance for location-based standards, especially when it comes to the ASCE standards that they were just mentioning. But this is where we're trying to really do is fill in the gaps of data and give it to the folks in the field who are going to be using these things. The cost of not knowing when it comes to utilities, I think Kevin had just mentioned there was about $30 billion in utility line strikes in the last, I think it was, he said 2023 or so. As infrastructure begins to accelerate, especially with the infrastructure bill that happened in the last administration, utility line strikes aren't just costly, they're dangerous. Standards like ASCE 3822 and 7522 are raising the bar, requiring more accurate geospatially located utility data. Compliance is no longer really an option. And this is where we believe our technology and others come into play, especially when we're trying to meet standards. When I say utilities aren't an option, I'll speak here a little bit. I mean, not utilities, standards aren't an option anymore. I'll speak a little bit to here shortly, where in Colorado, where we're based out of, some of these standards are now being required by like DOTs and other municipal government agencies. What we talk about with PointMan is an entry-level GIS for utility mapping. So PointMan is one of the first solutions to bring GIS to iOS or Android. It connects to industry standard GNSS receivers and pipe locators. So what we're trying to do is take that data that's already being captured in the field and bring it to a real world scenario that people can see right off of their phones. Other technologies that are trying to incorporate this stuff also are bringing in data from like CAD, DIS, data from GIS formats, and bringing it all to the palm of your hand. PointMan and others, we like to think of as specifically more of like the geospatial compliance part of things, where all of the information configures into a single spot where everybody can tend to see it, and also add information to that from the field so that everybody else on the team can see that. When I was talking about earlier, the compliance in Colorado, the DOT, they had kind of a unfortunate real world scenario that led to a pretty gnarly accident back in, I think it was 2013, that started pushing them towards compliance of SUE standards, specifically for the utility right of way. It was in 2021 that CDOT, Colorado DOT, mandated the use of SUE for their right of way compliance. Their goals were simple but critical: reducing utility line damages, improving accuracy, and complying with Colorado's one call law. PointMan became their platform of choice to meet those objectives because we were able to scale mobile GIS and to meet the regulatory requirements that they have. This is done by a variety of different ways. Within Pointman's platform and others like you have Esri and folks that really this is all about standardizing G, the compliance, the needs of what the folks in the field are looking at, so that you can circle back and take a look at, any of the data. You can verify the data. It's like that old adage, trust but verify. You have to be able to verify the information that you're collecting. And so with our platform, we support the ASCE standards built into the data schema so that folks, as they're collecting this data, all of the information coming from the high precision receivers, coming from the locators, will be brought into a platform that they can be used and then brought out of the platform for other third-party systems like your Esri's, like your CAD and others. Ken, you can probably speak a little bit more to kind of what this means for folks in the field, specifically when it comes to being able to use this data out in the field, whether it's coming from one way, from a client, or perhaps even going out to a client.
Yes, so obviously I use Pointman often with electromagnetic detection equipment, whether that's Metrotech or whether that's radio detection. And you can actually go out, connect to the line, and connect and collect XYZ data on the actual location of the line underground. And it's very accurate. Now, obviously, you're just locating the wire, but you're going to know exactly where that wire is. That wire is placed in proximity to the pipe that you're trying to locate, unless that pipe is steel or say copper, because obviously both of those conduct electricity. But you can basically collect the exact XYZ location of the underground facility without putting your eye on it. And again, have it in a KML file, KMZ file. You can ship it to someone in the office and they can download that data. KMZs and KMLs are very easy to import into Map3D, which is an Autodesk product, or Civil 3D. And then you can actually utilize that data. But what's also interesting is that if you have data that is in Map3D or Civil 3D, you can actually convert that data into a KML file. And again, centimeter accurate, go back out and actually put paint back on the ground, showing the exact location. So the nice thing about it is once you collect this data, it basically has more than just it does more than make a pretty map. You actually have data that you can actually go back out and put paint back on the ground if necessary to actually, locate and protect your underground assets. And of course, and the work that I do, we do this often, and it's really amazing just how accurate and how precise and, how good it works.
We follow the standards that are required in ASCE 3822. This is all according to the data schema build out within this platform. This platform is built in so that the folks who are using it don't have a way to really go outside of collecting data specifically for, in this case, the Colorado DOT. But these schemas are completely configurable by the end users. Really, what we're just trying to show is that using our platform or others, ASCE standards can be standardized so that folks can then take this data, collect it, and then hand it off to someone else. The whole point of data, the data collection, is to be able to reuse that information, not just now, but in the future. Inevitably, new construction happens, roads get expanded, utilities get relocated, having to do all of that high precision work again, when you already have it done the original, the first time, that is not only saving time, it's also cross verification of a lot of this data. It can help in the important things when it comes to safety, but also when we're talking about money aspect, it costs a lot less money to have to do this once instead of having to do this over and over and over and over again every time you send people out. So as far as this real world case is concerned, when we're talking about Colorado DOT specifically, their field crews use Pointman to assign quality levels from the field using the data captured pedigree that has been pre-assigned by Colorado DOT and coordinated with their CAD teams and coordinated with their GIS teams. So they're all speaking the same language, no matter where the data is going. If it goes into one system or the other, they have on the back end their CAD coding, which allows for data to be translated in a way that makes it pretty seamless from one system to the other. Really, the results kind of speak for themselves. With their enhanced data collection, the DOT has mandated this across the state now for use in all the right-of-way. What they're mandating really is the ASCE standards. It's just that because their preferred platform of choice is ours, they can also share that data out to folks by having them just download an app and then share that data directly to that user from their admin portals. They've had fewer utility line strikes. There's a lot more compliance when it comes to this data collection. And on some of these projects, we've worked with like larger construction firms. We're help reduce utility line strikes by upwards of like 90%, which, you know, if you have any questions on that, we do have some documentation in the chats, I believe, for you to be able to review those kinds of things. Primarily what we're trying to get at is the adoption of technologies like ours or others is really beginning to unlock the whole compliance of SUE. You know, SUE, you can do all this really heavy lifting work, but still that data tends to be locked in these silos of information. We try to unlock those silos of information by using the real world tools that are available to everyday folks. You know, most people have a variety of different brands of GPS, a variety of different brands of locator equipment, even perhaps, you know, GPR or other 3D imaging technology. Whatever is in the closet, using all of those tools to be able to produce these high quality deliverables is the goal here. What you're seeing here is just other examples of things that, for example, our technology can bring in: photos, live maps, you know, sketches, forms, those kinds of things. When we talk about high precision mapping, though, one thing I want to make very, very clear is that mobile mapping does not replace survey. It might help you enhance your data accuracy. It does bring RTK level mapping to everyday field crews and affordably too. Things like our technology and others can be hardware agnostic too. But at the end of the day, this isn't something that a surveyor or any person will just put their stamp of approval without first doing their quality checks. And that's why I just want to make it very, very clear that it isn't PointMan. PointMan isn't a survey replacement. It's just here to help and enhance, you know, the surveyors out there in the field so that they can go and verify this data with all the data collected within technologies like ours. This is just a quick example of showing kind of what a mobile mapping solution might look like. The technology here, or the screen here on the left-hand side, this is what the user in the field is seeing from their tablet that's mounted here on the survey rod. This tablet is connected via Bluetooth to this GNSS receiver and the locator here, pushing via Bluetooth all of the information right into the mobile mapping solution. And the user here can see their data being collected. This is what Ken was referring to when he's talking about doing data collection. Not only can you bring technology or the existing information from a third party, something like CAD or GIS, into a platform like PointMan, but you can visualize it on the screen for yourself and then also collect data in the field from the same platform and send it back over to the folks in the office so they can take a look at this in real world time. Ken, you probably have a lot more to say about, you know, that specific workflow, because I know that that's kind of your everyday workflow, working with, you know, a variety of different either utility owners or other clients in your area.
Yes, and what's really interesting too, this gentleman here is actually flagging the route. But a lot of times you can actually go out and collect the data and people would never know you were there. So it's not necessarily necessary to do that, but that's the beauty of this technology. Again, you know, not to mention, you can also stake out, you know, going back to the Autodesk products, if you had any line work in that product, and if it's centimeter accurate and it's survey grade, you can actually download that via KML into this software and stake it back out. So if, say you had historical data, you know, Norwegian Easting points or something like that that you collected 20 or 30 years ago, you can actually code that data and actually import it back into PointMan and stake out. So it's a very, very powerful and very useful tool.
Yeah, thanks, Ken. And quite frankly, you know, when I started into this, I don't know, 4 or 5 years ago now, I was kind of a newbie into this world, and Ken had a lot to say about teaching me how the technology is used by real world folks. Like every day, kind of unlocking what I show here is just unlocking your siloed information. A lot of this data tends to be locked up, like I said earlier, in a third-party software, in a GIS, in a CAD platform, in somebody's you know, desk, in a filing cabinet. But the folks who are in the field putting shovels into the ground, they're really the ones who need to be able to see all of this and then also communicate back what it is that they're seeing from the field so that folks in the office can have all the data that they need to make those really crucial informed decisions when they're making their designs or what have you. So our goal really with a platform like PointMan is to be able to unlock the power of the technology that you may have in your closet, but put this as a platform that is easy to learn. We call it entry-level mobile mapping, entry-level GIS, because it is a platform that can be easily used, but then of course it produces really, really great results. So with all that said, I know it was kind of a quick little presentation, but Ken, was there anything else you wanted to add to this as I'm kind of wrapping up here to bring in Dr. Nick?
Well, again, I've been using PointMan since I think 2019, and I just really feel that it's a great technology. It works well and plays well with other technologies. Again, if you have historical data, if you have CAD files, whatever you have, bring it, and we can show you how to utilize it to actually protect your underground infrastructure. And I just think it's a great product, and I really think that once people get an opportunity to see what it can do, it really solves a lot of the problems that we have, but we just don't know the answers to. So feel free to reach out to us, reach out to PointMan, and they'd be more than glad to answer your questions or get in contact with me. I'll be more than glad to, tell you my experiences in great detail of, how I use PointMan to solve a lot of the problems that we come upon on a daily basis.
Thank you, Ken. I've had the questions up here. If you have any questions, please drop them into the comments. We'll make sure to circle up and answer them here at the end. Next up, it's an honor to present Nick from Bad Elf. He'll be jumping in with us. And thank you, everybody, for joining the Connect Me conversation. I will be circling up with it in the question and answers here at the end of the meeting. Thank you guys so much. Talk to you very soon.
All right. Thank you so much, Marvin and Ken. Really appreciate that. Let me go ahead and share my screen here, and we will get going. All right. So I am the last presenter today, and following this, we will have a Q&A with all the panelists back on. So please stick around for that. Thank you for all of the previous presenters and hosts. I really appreciate that. As one of the sponsors of this event, I just want to say thank you for spending your time to help educate some of the masses and other people in the industry. Today, I'm going to be wrapping us up with a little presentation I call Precision Without the Price Tag, SUE Mapping with Bad Elf. So let's jump right in. Before we get too far, I want to ask a few questions. So we have another poll. This is more of a solutions-based poll. So you should see a screen that popped up on just now. And it's asking, do you currently implement a GIS solution for SUE? Are you interested in implementing a GIS for subsurface utility engineering? If you have a GIS solution, would you be interested in speaking with somebody to see if you could maximize said solution? And last but not least, would you need any high accuracy GNSS or any devices to collect high accuracy data? So go ahead and click those, fill that out. We will review it here in just a moment to kind of see how everybody is solutions-wise so far today. While that is tabulating, what we are going to be talking about is what is Bad Elf. So I'm sure there are a few of you out there that have no idea what Bad Elf is. I want to really focus just on one issue kind of primarily, or a set of issues that I say plague the subsurface utility engineering market. We're going to talk about Bad Elf's affordable GPS solutions. We're going to talk about some very affordable and simple mapping apps that make your life easy, like PointMan and Esri, and how all of this really is pushing towards that compliance for the ASCE SUE standards, and then a little bit of a call to action about Bad Elf's geospatial enablement team. So before we go any further, let's go ahead and show the results of the solution poll. Let's see how everybody is doing with the solution. All right, so it looks that right now about 46% of you are saying that you do use GIS for SUE. That's awesome. Oddly enough, 46% of you also said that you're not using it 8% said not sure. Let's see here. Are you interested in implementing a GIS solution? Another pretty equally distributed question. About 25% saying yes, they're interested, about 25% saying maybe we're interested, about 25% saying I'm not interested, or last but not least, 25% saying that they're already implementing it. So pretty equal distribution across the attendees today. It says, if you need a GIS solution, are you interested? Looks like there's a good percentage of about 25% of you that are interested. So we'll be certain to be following back up with you after this event. So just keep an eye out. We'll make sure that any of your questions are answered or anything that you may need to implement these types of solutions. And last but not least, do you need high accuracy GPS or global navigation satellite systems to collect field assets? It says predominantly most of you are saying no, which leads me to believe that mean you already own these types of high precision devices. But still about 26% of you saying that you do need high accuracy GPS. So that means that there are still a lot of you that seem to be adopting this technology. So hopefully you're learning a lot today. And let's go ahead and jump in. So who is Bad Elf? Bad Elf, we've been around for about 15 years. We are not a skateboard company. In fact, we create GPS receivers that's been empowering different industries like GIS, survey, and public works to capture high accuracy data for quite some time now. Originally, we jumped in the aviation and marine industries. If you're a pilot or know any pilots, you may have seen our name ubiquitous to some of the mapping apps and GPSs for pilots commercially and privately. One of our calls to fame is we create a rugged, reliable solution that works on iOS, Android, and Windows. And so we have an MFI certification for apps running on Apple. We work with Android, and if you are one of those people that still use Windows, we can hook you guys up too. And this allows us really to play well with all different types of field mapping, utility locating, and asset management software. And again, we are the hardware that gives you the position to do all of this SUE compliance. And last but not least, we employ you or implore you to leverage our industry expertise to help get your GPS workflow and your GIS workflow up and running. We can help simplify it, keep it simple, stupid, the old Navy adage. We don't need to save the entire world or fix all the world's problems, but how do we get right to your project? How do we get you a platform? And how do we stick to your budget? So here is the issue at hand at the end of all of this today that I run into a lot because I talk to a lot of people doing SUE, whether it's a one-man team, like a mom and pop shop, to a large multinational engineering firm like Fortune 500, or you're actually in the government, so state and local government or Fed government. There are a lot of parts to subsurface utility engineering, from design to construction to maintenance. Today, we're kind of really just focusing on this stuff's already been put in the ground. What do I got to do? And so here are the issues. The issues are there are no survey crews. Are you one of these people out there that are like, I can't get a survey crew. Like my company doesn't have a survey crew available, or my organization only has 2 surveyors and they're so busy, I can't even sign them up. Or perhaps certainly with budget cuts and things, traditionally, the cost of surveying equipment was super expensive. GPR, total stations, GNSS. It basically knocked out the masses from being able to do this work. So you don't have enough people to do it. The equipment is too expensive. And quite frankly, if you don't have it in-house, if you don't have people in-house, or you don't have equipment in-house, then you have to look at outsourcing this. And that's just as expensive or more expensive. And there's a huge time component when you have to outsource this work. This leads to the demand for reliable and accurate data. SUE, subsurface utility engineering, we're talking about mitigating pipe strikes. That is critical. A pipe strike could kill people, if not multiple people, and cause infrastructure damage into the billions, right? So there's not going to be less things going into the ground. We're only going to have more and more infrastructure. And so we have to have reliable, great data. And again, reliable, great data used to be an old boys club. You had to spend a fortune to go get that data. And you had to go find somebody that had a whole bunch of credentials behind their name to go collect accurate data. Now, I'm not saying that land surveying is going away. I'm going to echo what Marvin said. These are tools that surveyors and other mapping professionals can use. But the days are way long gone of only having one surveyor and one total station to go do this type of work. We also want to push for automation, for streamlined workflows. The idea of GIS and AI and machine learning. How do we get through this faster and quicker and more reliable, right? We also have like all kinds of different devices out there, like Marvin mentioned, and environments and offices and geographies and different compliance rules, whether that's a state and local rule or the city, Society of Civil Engineers. We really need to find a budget-friendly accuracy device for non-surveyors. And here it is too, the equipment needs to be easy to use. You don't need a 6-year, 4 years of a degree and 6 years of an apprenticeship to go out and map these stuff. Like nowadays, you get out of college, you know how to use a cell phone, you can effectively go collect high accuracy data. And so that's where Bad Elf comes in. We create devices that utility professionals go out and use for subsurface utility engineering, among other things. We have two major products. We have the Bad Elf Flex and the Bad Elf Flex Mini. The Flex is a super versatile unit. You can use it with SBAS or satellite corrections. You can use it with real-time kinematic terrestrial corrections. You can use it with base and rover radio corrections. It is effectively a Swiss Army knife, or, it literally does all the things that you need, including making Julian fries. If you're off grid, you can use base and rover. If you're in an urban area, you've got RTK via Entropy, and your centimeter grade accuracy for fractions of the cost of what this type of equipment normally would cost. Or the Bad Elf Flex Mini, a much smaller device of ours, in a near survey grade into the few centimeter accuracy range. So depending on where you are, what you're doing, we have devices that are going to get the entire scale of what type of accuracy you need to collect. And again, these devices Bluetooth connect with your phone or tablet. Then you fire up your app of choice. And so here's the Flex. This is our fully survey grade device. This is great for high end, the best, level A utility detections. This is our Flex Mini. This is a near survey grade device. It can also get accuracy into the centimeter range. A little bit more affordable, easier to send out to the masses if you need more people collecting data. We saw PointMan. So PointMan, full disclosure, is one of our business partners. We've been working with PointMan, I honestly, since before Marvin was working at PointMan, I think he said about 4 years. You can see that we are an integrated GNSS or GPS as one of the drop-down listed units that you can use with the app. What's really nice about this is when you connect our device to your cell phone or tablet and you fire up the PointMan application, you can then also connect that locator in. So if you're using that underground utility locator, you've now glued together X, Y, and Z plus where the utility is, and then you can be exporting that data to different formats. I do want to make mention that we are a agnostic company when it comes to different types of solutions and apps. We work with most of them on the market. So we're kind of highlighting PointMan today and Esri, but safe to say that if there's a geospatial app out there, we work with them. When you get back into the office, we are also an Esri Gold partner. We sit on the partner action committee as, I believe, the only GNSS manufacturer, or one or two of. And so what we really like to proselytize and promote is this, getting all of this spatial field data that used to be super complicated and expensive. Now you can get it easily into a GIS. You could be using GIS apps like Field Maps to collect these data, or something like PointMan that can export to a shapefile. And inevitably, all of these are getting back into that GIS, right? And so why do we need affordable GPS? Well, because we have survey crew shortages and the cost of traditional equipment is super expensive, and can't always outsource it because of time constraints and money constraints. And we need automation for repeatability. And so this is where we are. So with Bad Elf, I mean, it's like 4 simple steps. Go collect data, right? So it's super easy. Your GPS, Bluetooth connects. You can fire up PointMan. You can then use your utility locator of choice. And you're now mapping and flagging your utilities. Next, these data directly go into something like an Esri GIS dashboard where we're seeing real-time analytics. If you're using the Esri field maps or Survey 123 or Quick Capture apps, you can be actually pumping data right into your GIS databases. So constituents and stakeholders are watching this real time or near real time, displaying these data you're collecting. Once the data is in the GIS, we can help you script and actually write routines and show you how to export all of your data to CAD. The days are long gone that CAD and GIS don't get along anymore. In fact, we're a match made in heaven. I absolutely love it. So GIS and CAD doesn't need to be two different departments and two different buildings that never talk to each other unless it's the holiday party. That's not the case anymore. We've made this all really easy where everything jives together. So get it to your CAD system. And then last but not least, you're writing your report. And so the GIS can actually take the data from the field, the attributes you collect, the locations you collect, the pictures you collect. You can automate an actual report. So the GIS is pumping out an automated report that's stylized. And then you've got your CAD that we already saw. And so then your principal engineer, your PE or your ROS or whomever is stamping this data can stamp the map and you've got a solution. And again, it's super affordable these days. It's very easy. You know, you can have a high school degree and blaze through this. Do your data need to be checked by professionals? Yes, absolutely. Are you going to go out and do a boundary survey with this? If you are a surveyor, yes. You know, got to be careful, need to be trained. But what we've done is we've democratized all of these solutions so that everybody in the industry can now go do this. And if it goes back to my original point, there's no reason to not go collect SUE data. If 811 is called and there are paint stripes on the ground, you should be able to send your GIS crew out, like the guy sitting next to you doing GIS maps, go out on a Friday where those paint markings are, take your Bad Elf GPS or some other GPS and your app of choice, maybe Field Maps or PointMan, and go collect the data. There's no reason we shouldn't be contributing to the digital twin anymore. It's easy, it's affordable. You don't need to have a doctor's degree to go do it. And you don't have to wait on that survey crew that seems to be booked for the next 3 months, okay? How can the Bad Elf help you get here? We're gonna wrap this up. I run our geospatial enablement team at Bad Elf. We come alongside our hardware to provide custom solutions and training and consulting services. Our whole goal is to take you from 0 to hero. If you know you need to do utility mapping and you don't know where to get started, we are here to help. We're also a GISCI or GISP endorsing organization. We have several Esri certifications, things like state and local government and federal small business. We are on GSA Advantage. We do very large trainings like this. This was City of Tempe, Arizona, where Arizona State University. We trained 20 different departments, or about 20 people in 18 different departments of public works to utilities on how to use Esri, right? This is not even the field side of it. This was a week long of training in the office. So at Bad Elf, we don't just hand you a GPS and say, go for it. We help you do all of it. And so I want to leave you this. This was one of our customers, Jody, president of Magnify Utility Engineering, talking about Bad Elf equipment. And Jody said, we recently acquired the Bad Elf Flex Extreme to receiver to streamline field tasks and improve data efficiency. That's it. Field tasks, improve data efficiency, and the Bad Elf Flex met all their goals, and they loved working with us. So if you have any questions, I am the last speaker. My email is on the screen. You can also call my cell phone. And without further ado, I'm going to go ahead and pull the rest of the panelists back onto stage. If you've had any questions, this is going to be the time to ask. I'm going to stop sharing my screen as well. And Mark, I'm going to hand the mic over to you.
Yeah, great. Nick, love your passion and love the details. And we really had a range of content today, from passionate storytellers like myself and Nick to folks who are using software on a day-to-day basis and you know, seeing benefits. So good stuff. I had a few questions come in. Going to maybe talk to those first and throw in a few other topics just for us to bat around for a little while here. Maybe that last question, a little bit provocative. So there's no need for utility design engineers anymore. You know, that's
actually,
yeah, Kevin, you want to start with that?
Yeah, actually, per the ASCE 38-22, the work should be under the supervision of a licensed land surveyor or a civil engineer.
Okay.
Yep. Which is
So there
why,
is a need for a designer,
yeah,
licensed
I think
designer.
Nick and I kind of leaned into that too. It's like these tools aren't here to replace these professionals. You know, they're industry expert, their expertise in, you know, the surveying engineering field is still valuable, and it's also part of the ASCE requirements. It's just that we're talking about the way that the data is collected doesn't necessarily have to be by that professional. It still needs to be verified by those professionals.
That's exactly it, right? So you may have a couple registered surveyors or PEs on staff, but you may have 30 technicians, right? Assuming that the technicians are trained correctly and they're using the equipment correctly and things are being verified and checked by that professional, you've created a system where you should be able at this point to confidently collect data. And one of the things I do want to mention, Esri, Pointman, these new GNSS receivers, they provide metadata as well. And so behind the scenes, we capture a lot of information that, say, somebody like Kevin as a PE and then PLS, they may look at to judge how the data was. What was the PDOT? What was the RMS? How many satellites? What was my baseline? You know, and the hope would be with somebody like Kevin on staff, Kevin's going to teach those people on maybe how to check in, right? So checking in at your location at the beginning of your job and your end of your job. But the idea is it's now easy enough that we can teach more people at your organization to collect that data confidently.
Certainly. And I mean,
So, go ahead. I was going to say, there's another question that came in that was a little easier, but if you want to wrap this up, Marvin?
No, well, primarily, you know, I see it from kind of more of a theoretical point of view because I'm not the person in the field collecting this data, but someone like Ken himself who is, he talks to engineers and surveyors day in, day out, collecting this data, pushing it out to them, and then also receiving data from them so that they can do verification out in the field, that level D data, you know, when it comes to trying to find this information. So all in all, yes, those professionals are still required. You know, it's just a part of how this is done is really what we're trying to get at.
Yeah, good deal. So questions about accuracy. To meet quality level A, what are the accuracy requirements for survey hardware, for example, sub-meter versus sub-centimeter? I think there was another question about accuracy earlier, but maybe just talk about that in tech and its level of accuracy and maybe
Kevin, do you want to? I was going to say, Kevin, do you want to talk? I think you're probably the most qualified.
So the accuracy is really based on the utilities, the survey utilities or the collection utilities and tools that are being used. And usually the licensed engineer or the licensed surveyor, when they produce the map, the final product, they provide the tools that were used to collect the data, and they provide the accuracy that this equipment has. So the end user know what accuracy they are looking at.
Yeah,
I could say as well. Oh, go ahead, Ken, please.
No, accuracy to me is, can you get back to what you were trying to capture that on? And I can tell you personally, I have dug up many lines and, you know, where we located it and found, you know, the item. I had a gas valve I was looking for one time on Fort Myers Beach and collected that on it months prior and had to go back to find it. And obviously, you know, you've got that cast iron plug that goes in the top of the valve. Well, of course, when I collected the data, I collected in the middle of the A. And when I found the gas valve, again, same thing, the middle of the A. So again, you know, this technology is very accurate. You know, the bad alpha is accurate. You know, the MLIDs are accurate. You know, you just need, like old saying, trust but verify. And to me, the best way to verify it is go back to it and see if you can find it. You know, dig up stuff that you found with electromagnetic tool. And of course, again, if you're locating plastic pipe, you're locating the wire that's associated with it. And what's interesting is that I've gone back, you know, where we located the gas line and we dug it up and we found the wire. So, you know, and the pipe was close to it. So again, it's very accurate. And you got to realize a lot of industry, you know, and the utilities use the electromagnetic tools from radio detection and from Metro Tech. And again, they've got a proven track record, because obviously that's what they use to protect their underground assets on a daily basis. So the nice thing is just now there's a way to integrate all this technology, put it together, document it, and again, trust but verify, collect it, go back. But I'll tell you from personal experience, very, very accurate.
Thanks, Ken.
Yeah, can you maybe talk about it, maybe even elaborate on what affects or influences the accuracy, what improves it, or might even, challenges to ensuring accuracy?
Yeah, there's
Go
the
ahead.
truth is there's not really much easy about accuracy. We want to sit up here and tell you that it's easy, but no, there are several things. So the major thing that's going to influence accuracy of a GPS, and that accuracy then could be tied to where the utility locator is or that GPR is located, or even an above ground asset. So when satellite signals come down from space, they are radio signals, and radio signals are a line of sight signal. If you can think back to your like middle school electromagnetic spectrum of where energy lives, like visible energy and X-ray. So radio signals, they literally bounce off of objects. So let's say Ken was somewhere in downtown, West Palm or Fort Lauderdale, he was saying, and he's next to large buildings. The concrete, the metal roofing of that building is going to eat GPS signals alive. And what will happen is they will bounce off of that impervious surface, causing something called multipath error. The other thing where we see multipath error is maybe you're collecting data under a tree. So Ken, again, is underneath canopy in South Florida, lots of bush. The tree, the foliage can actually cause that same issue. So what happens is, this radio signal bounces off of all of the surface, and it causes the GPS time to be incorrect, which effectively makes the location inaccurate. So what you'll see a lot of times is when you get close to buildings, surveyors will have a lot of tricks up their sleeve to get that position next to the building, which also may mean taking out a different tool like a total station or a pull tape, or collecting that data remotely. So that's multipath error. Another fun thing is your body is a meat shield. So if you're holding the GPS, or let's say some of the utility locators have a GPS built into them, and if you're hovering over the locator, your body is actually causing that GPS signal to be obstructed as well. And so that's like the major issue. But the other thing I would also mention is this access to what we call RTK. So real-time kinematic corrections. These are terrestrial-based corrections that make those radio signals better. So long story short, radio signals is like a 4-cylinder engine. You add RTK corrections to it, now you've got a V8 with turbo. So what happens is that will get you, say, from sub-meter accuracy on most devices down to centimeters or fractions of an inch. And so be aware what service you're using, how far that distance is to that service, or that baseline distance to the cores, whether it's Bad Elf or some other provider. Talk to the people you're getting your GPS and equipment from. They should be able to discuss this with you. One thing I'll be quiet, Marvin, maybe you want to jump in after me, but we have a partner between Pointman and us. It's called GeoNet, and so they're a public RTK, and I believe you can use it in Pointman as well. But a lot of these networks are public now and very open to being on there. So I don't know, Marvin, if you have any thoughts about RTK.
No, that's a great point. As I've come to realize this, the more and more technology that people are starting to use in their hands, the more things people have to know about. And when I talk about a platform like Pointman, we talk about it being one of 3 shared stool. You have to have the mapping software, you have to have a high precision GPS, but also the correction service, which I liken to a high precision network, like a Wi-Fi signal. To kind of simplify it, you can get standard GPS, which is on your phone. That's great when you're driving down the road looking for the Starbucks, but when we're talking about high precision gas lines, you're going to want something a lot higher accuracy, and that accuracy is going to come from that corrections network that you connect to. So things like GeoNet, things like Point One Navigation, which is also a partner of ours. And like in Florida, for example, they have a free correction service. Out here in Western Colorado, which is where I'm located, there's a free correction service. So those corrections are crucial to be able to bring this high accuracy data to the device that you're using, no matter really what the device is, those three things are typically the things that make this work: the hardware, the software, and then the corrections.
Great, that's wonderful. I mean, I get asked a lot about, sort of friends and family who know anything about GIS, might have a negative impression about its accuracy. That really was good stuff for me to now have responses back to my friends and nothing else.
Yeah, definitely.
Question came in that actually was really interesting. Kind of, again, kind of a lay person question I would think about. Can you just connect to the utilities networks without permission? I mean, is that something engineers can go out and do? Or is there a process for asking a utility if you're
No,
connecting
you should not.
Yep. I think Kevin said it too, though. I mean, as long as you're not damaging what you're connecting to, you got to be real careful because it is something that you don't own. But yeah, from my understanding, things are, especially if we work a lot in the right of way, public right of way. So if things are sitting in that, typically they're just kind of there for the taking as far as mapping is concerned. But I mean, I know there are in some special facilities that you might need like permission to get onto those facilities and stuff, but for the most part, generally speaking, I don't think there's too much back and forth between utility owners or not.
Good deal.
However, for the potholing process, like a lot of the utility owners, they require that a representative from there on their end to be at the job site.
For potholing.
So for potholing.
Anything
if you are doing pothole for a gas line, so a lot of the gas line companies they require to have one of them, a representative from them to be on site when you are digging.
Mm-hmm.
Makes sense. Nick, Bad Elf. Someone asked a question. What is the function of Bad Elf? Do you want to maybe just kind of give a real quick recap?
Yeah, so Bad Elf, we are a low-cost alternative GPS. So you Bluetooth connect our device to your phone or your tablet of choice, and we provide a latitude, a longitude, and an elevational value to your device. And we're very similar to the Trimbles, the Topcons, the Leicas, the MLids, the EOSs. There's StoneX, Javad. There's a lot of devices out there these days. And as an educational webinar, I would just challenge everybody to do your due diligence. If you are looking for a new GPS to provide accuracy, try out a couple different ones. Nowadays, like the Bad Elf GPS is at a fraction of a price going to be just as accurate as some of the much more expensive units. But I will also say that there are really good units across the board. I would also suggest that when you're looking at a GPS manufacturer, look where they're designed, where they're built, do they have stock? And probably most importantly, who you're dealing with, right? Like, are they friendly? Do they return your calls? Are they actually, there to help you out? But yeah, we are a GPS. And I'll say one more quick thing. Your cell phone has a GPS built into it, right? It's an integrated GPS, but your cell phone is not going to get you much better than about 15 feet of accuracy, or what we call precision. The moment you need to get to mapping grade at a meter or better, or survey grade, lots of ways to define that, but let's say 0.2 of a foot vertically. Bad Elf is a way to do that. So yeah, we are a low-cost GPS.
Great, thank you for putting that all in context. This has been a tech heavy, tech-friendly panel here. I want to throw a couple questions out. 3D has been my thing, since its earliest days. It seems that we're still kind of at a 2D way of representing things. Anyone exploring 3D? Marvin is point man. Any of your customers taking the content and putting it into more 3D visuals to understand things?
Oh yeah, we've
Head
had
shaking. Yeah.
Yeah, especially in the construction space. I'll give you a great example. So when we're doing test holes, for example, potholes, the exposing of the utilities out in Colorado DOT, there was a massive project where they were doing a utility relocating in central Denver. They were dropping a 10-mile stretch of highway about 50 to 100 feet into the ground, and then they connected a old neighborhood that was parted when they put that highway in the 50s and 60s. So in dropping that, at one point, that was the largest utility utility relocating project in the country. And what they did before that was take 40,000 test holes onto this, brought it into a platform, which was ours to collect the data, but then they moved it into things like GIS. They made their utility maps and then re-uploaded that into our software where they had, you know, kind of your XYZs, but then folks in the field could take a simple tool like Bad Elf or you know, Trimble or something like that, see the utility data on their phone, and then stake back to that data, knowing also an elevation of where that utility is based off of the surface. We've had other folks who have taken this data and made like 3D designs, pushing it through things like Pix4D, other, you know, platforms that can show the data. We've even had one of our GIS scientists here at ProStar has taken that data and used things like Apple Vision to be able to see these things in 3D. Now, those are kind of a little bit more futuristic of how things, but that's where the industry is going, from viewing things in 2D to be able to use this 3D data in a variety of different ways. And I'm sure, I mean, Ken, you might have some more to say to that in a real world sense, but, you know, there's definitely a really cool way that people are starting to use all these technologies.
Yeah, I'd like to piggyback on that. And basically, the data that you get via PointMan, again, you get KMLs, KMZs, CSV files. You can take a CSV file, turn it into a notepad file, import it into Civil 3D, and actually get a three-dimensional depiction of whatever the data you've collected. So again, I guess I always say your imagination is your own limitation. Not to mention, I just want to shout out two companies. One is EnviroCal, and the other one is Reduct. They have a gyroscopic mapping tool that you can actually push through a pipe, and then they can give you the shape file, KML file, KMZ file. You can take that file, put it into Map 3D, and actually visualize it, you know, the utility in 3 dimensions. Not only that, we actually had a project in here in Fort Myers where we hired a company, I won't mention which, but they came out, they gave us the data, and we were able to stake out using PointMan the actual running line, you know, of the utility that we couldn't locate. So again, there's so many solutions out there. And the thing I always like to say is that all roads lead to, well, PointMan. All roads basically lead back to where if we work together, we can solve a lot of the problems that we've had in times past. So if you've got a question, chances are we have a solution, you know.
Great. Go ahead, Nick.
Yeah, I want to just throw one more real world example in. So where I live in Texas, Texas Department of Transportation, TxDOT, it now has, and we've all heard of this term, the digital twin, right? That's everybody says it these days, and it's cool and all. But at TxDOT, they have what's called digital delivery. So it's now a required process when you submit your engineering jobs on a road project, you've got to submit it in 3D. It's absolutely part of the submission requirements now. And I would agree with Ken and Marvin, and I'm sure Kevin would agree as well. We're not going to go less 3D, you know, it's only going to be more 3-dimensional space. So yeah, and like I said, TxDOT's, they're requiring that information now.
Model as a legal document is a term that's going to start showing up more often. All right. You know, we're down to just a couple minutes left. Let me wrap up maybe with this. You know, questions coming in about, you know, how much does one of these cost? How much is it? And you know, can I implement this for a design team? I'm going to suggest, you know, anyone who's got, you know, ongoing interest, you know, check out the resources, and whether it's, you know, an Esri GIS system type scale, whether it's the capabilities of PointMan, whether it's Bad Elf and its services. You know, we're each here, you know, Kevin as a service provider, you know, in your area, we're all here to answer your questions. And that might just be a great way of diving another level deep. And I think our contact information is also available through Connect Me. So great content, great discussion here, great questions. Thank you for submitting those. And with maybe just a few seconds left, I'll say goodbye and thank you. Goodbye and thank you.
Yeah, thanks everyone for joining us today. Appreciate you.
Thanks, everybody.